Consider the titration of 25 milliliters of a 0.100 molarity HCl with 0.100 molarity NaOH. Calculate the pH initially after 5 milliliters, 20 milliliters, 25 milliliters, 30 milliliters, and 50 milliliters. So for our initial pH, we know that our base NaOH has not been added yet. So this part is pretty easy. Since we know that a strong acid is going to equal our H3O plus because it fully dissociates, we're just going to take the molarity that we are given in the equation and we're going to consider that our H3O plus. pH is just a negative log of H3O plus. So, take the log of this. So our answer for the initial pH is going to be 1. Next, we're going to find the pH after an addition of 5 milliliters of NaOH. So now we're going to have to find both of the moles we are given. So we're going to take .005 liters is equal to 0.100 molarity if we're going to find the moles of NaOH. So our moles of NaOH is 0.0005 moles. We also have to find the moles of our acid. So we're going to be given 25 milliliters, turn that into liters, get 0.025 liters equals 0.100 molarity, and our moles of, what is this? HCl. Okay. Okay, now we need to set up our neutralization equation. So this is HCl being titrated with NaOH. So NaOH is being added to HCl. What this is going to turn into is H2O plus NaCl. Okay. Now we're going to plug in our moles into this equation. So we found that the moles of NaOH was 0.0005. Moles of HCl is 0.0025. Okay. We're also going to know that over here, our conjugate base is 0 right now. So now we're going to use up all of our NaOH since it is the lesser product or reactant. So we're going to subtract it, and then we're going to be adding it over here. This is going to turn into 0. This is supposed to be 0. 0.0025 minus 0.0005 is 0.002. This is just going to be 0.0005. Okay. Now, really, you don't need to do this part. I just realized that. So ignore everything I just did there. Sorry. I mean, at least you know this is what the outcome is, but to solve for the pH, you're really only looking at the strong acid. So now that we have found our new moles of our strong acid after some of it has been reacted with our base, we're going to put it over here, and then under it we're going to put the liters that was used. or, you know, used in the equation. So we know that it is 0.025 plus 0.005, which is 0.03. So 0.002 divided by 0.03 is this. And then we're just going to take the negative log, since how I set up here, since it is a strong acid, it is just going to equal the H3O plus, and the pH is equal to the negative log of HCO plus. So we're going to take the log of this, and we know that our pH is 1.176. Okay, next, finding the pH after we added 20 milliliters of NaOH. Okay, so here we're just going to do the same thing. Set up our equation again. Since we're not really dealing with the product side over here, I'm not going to continue writing it over and over, since there is something happening here. That's why I showed you that this will just come out as this. H2O is ignored because it's aqueous, and you only really deal with gases and liquids. No, sorry, oh my gosh. H2O is liquid, but you only really deal with gases and aqueous when you're doing these kind of equations here. So I'm just going to write this, but just know that this still does happen. So HCl plus NaOH, we know that our HCl moles is 0.0025. And we just found that this is that. I'm going to subtract. So now our new moles of HCl is 0.0005. 0.0005 over 0.02 plus 0.025. 0.45, so 0.0005 divided by 0.045 equals 0.01111, and you know. Let me just make sure I wrote that. Okay, yeah, I did. Then yes. Okay, now we're just going to take the negative log of this. So our pH is now 1.9. Okay, so now we're dealing with 25 milliliters. So the thing about this is, like I said, we have 25 milliliters of HCl being in this equation already. So if we added the same amount of NaOH, since these both have the same molarity, it's just going to get the same moles. And when the moles of an acid equal the moles of a base, if they're both strong, the pH is just going to come out as 7. Because they're both kind of the same. If it was a weak acid and a strong base, that would be different because the base is stronger, so it would be over 7, or like vice versa. If it was a strong weak base with a strong acid, it would be less than 7. But since they're both strong acid and strong base, we know that the pH when they are equal is 7. So that's easy. But now it's going to change once we start adding more than the equivalents. Okay, so now that we're adding more than the equivalents, we're gonna still do the same thing where we find that the moles of NaOH is going to be 0.003. That step is still the same as the rest of these. We also found the moles of NaOH for the rest of them. But now what's going to happen is when we write our equation here, so we have HCl plus NaOH, we have 0.0025 of HCl and 0.0030 of NaOH. So this now has more than our acid. So this is now the one that is in excess. So we're gonna start taking away the acid from the base, and we're going to calculate our pH based on the excess base that we have. So let's take away our acid. We're left with 0.005. This is going to be 0. We're going to do the same thing. We're going to find what this is. We have 0.03 liters plus 0.025 liters. Which is just 0.055. Okay. So that is going to come out to 0.009. That is our molarity for our base. So the base is going to start affecting the pH, since this is what we have in excess, like I showed over here. So what we're going to do is, we know that the strong base is going to be equal to our OH value, and we know that POH equals the negative log of OH negative, and we also know 14 minus POH equals pH. So that's what we're going to be using here. So we have the molarity here. Let's take the negative log of it. You get 2.04. Okay, so now let's do 14 minus 2.04. You get 11.96 is our pH. Okay, the last thing that we're going to be doing is we're adding 50 milliliters of NaOH added. It's the same exact process as we just did with the 30. So we're going to find our moles of NaOH. So moles of NaOH equal 0.005. All I did is I used the same equations of this. So that's all I did here. I know that we have 50 milliliters converted to liters times the 0.100, which we were given, and you get this. So let's write out our equation. HCl plus NaOH. HCl is still 0.25, I believe. Moles. Was it? No, it's 0.0025 is our moles, and then we're going to have 0.005. But you know, this is really 50. But okay, this is still the one that is being taken away. This is still in excess. So you're just gonna get this. Now let's use that and find the molarity. you get this. Let's take the negative log. And then let's take that away from 14. And you get 12.53 is our pH.